Friends, all you are welcome to Math Unique Plus video. Today's matter of discussion is some problems with the help to solve this with the help of the important properties of definite integral. Okay, let us start. 1, 0 to 2 modulus of 1 minus x dx. Using the property of modulus, we can write 1 minus x greater than equal to 0, that is x less than equal to 1, and then minus of 1 minus x when 1 minus x less than 0, that is x minus 1 when x greater than 1. So this can be, 1 is the intermediate point, so this is to be split up into two parts, 1 minus x dx and this 1 to 2 modulus of 1 minus x dx. So 0 to 1, that is less than 1, for less than 1, 1 minus x dx, and 1 to 2, that is greater than 1, this is equal to x minus 1 into dx, that is x minus x square by 2, 0 to 1, x square by 2 minus x, 1 to 2, substitute the value, 1 minus half minus 0 plus 2 minus 2 minus half minus 1, that is half plus half is the 1, and hence next number 2, 0 to 6 pi sine to the power 4x dx. Using the property we know 0 to na fx dx equal to n into 0 to a fx dx so long fx plus a equal to fx. Here fx equal to sine to the power 4x, that is f pi plus x equal to sine to the power 4 pi plus x, and this is equal to sine to the power 4x equal to fx. So this can be written as 6 into 0 to pi sine to the power 4x dx, hence proved. Then number 3. Then number 3. 0 to pi cosine qx dx equal to 0. Without using the property, we can do like this. 1 minus sine square x into cosine x, and this is cosine square and cosine qx, and z equal to sine x, then dz equal to cosine x dx. So x lower limit 0, upper limit pi, and z equal to 0 and 0. So 0 to 0, 1 minus z square into dz, and this is equal to 0. And alternative, using the properties I equal to 0 to pi cosine qx dx, using the property 0 to a fx dx, a equal to 0 to a minus x dx. Using this property we can write 0 to pi cosine to the power 5, a means pi minus x dx, and this is equal to 0 to pi minus cosine to the power 5x dx, and this is equal to minus I. Then I, by transposing I plus I equal to 0, or 2I equal to 0, I equal to 0 by 2 equal to 0. So using properties and without using the property. Then 3 is complete. Then number 4. 0 to 2 pi cosine x dx 1 plus sine square x dx. Without using the property, z equal to sine x, then dz equal to cosine x dx, and limit x 0 and 2 pi. So z equal to 0 to 0. So 0 to 0 dz by z square plus 1, and this is 0. Alternative 0 to 2 pi cosine x dx 1 plus sine square x, and using the property this can be written as 0 to pi cosine x dx by 1 plus sine square x dx, and this is I equal to, and so this is equal to 2 into I1. This part say this is I1. Now I1 equal to 0 to pi cosine x dx by 1 plus sine square x. This can be written as 0 to pi cosine of pi minus x 1 plus sine square of pi minus x and dx. and this is equal to minus 0 to pi cosine x dx by 1 plus sine square x dx, and this is equal to minus I1, and transposing 2I1 equal to 0, therefore I1 equal to 0. Now I equal to I means 2I1, 2 into I1 means 0 equal to 0. So using property and without property. Okay, so we can do any of the process. 5 minus pi to plus pi x into x square 1 plus x square without using the property. Z equal to x square, dz equal to 2x dx, and this is equal to half z e to the power z, and this is dz by 1 plus z square. What is the limit? Plus pi and minus pi and plus pi. So z equal to pi square and pi square. So upper limit and lower limit becomes equal, and half into 0 is equal to 0. This is alternative. Alternative, minus pi to pi x e to the power x square dx by 1 plus x square. We know this can be written as 0 to pi fx plus f of minus x dx, where fx equal to x e to the power x square by 1 plus x square. What is f of minus x? Minus x e to the power minus x also, that is x square, and 1 plus minus x also x square, that is minus of fx. So this will tend to 0 to pi fx, and f minus x means minus of fx and dx, and this cancels out, and so 0. So if we can do any of the process. Okay, so everything requires a little practice. Okay, thank you.